Question 2. A stone is thrown down the slope as shown. Determine the magnitude u and the direction theta of its initial velocity so that it will rise 12 meters and still have a range of 50 meters down the slope. Now, the presence of the slope is confusing in this question. We can completely ignore it because it's, again, just a matter of going between the beginning point and the end point. And we know everything we need to know about this question. We're given the gradient of the slope here, 3, 4, 5. If it's 50 meters, then we know that this is 30 and this is 40. And if we zoom in and look at the velocity vector, u, then really the question boils down to finding two unknowns. ux, the x component of the speed, and uy, the vertical component. Now, the first part of the question is a question: what speed uy is required for it to move 12 meters vertically before it comes to a stop? This we can find by applying constant acceleration. We know that it starts with v naught y, the initial speed in the y direction. It reaches 0, so it comes to a stop. So we know that its initial speed must be 15.34 meters per second. Then the next stage is working out, well, how long does it take, given the initial speed that we've just calculated in the vertical direction, for it to go up 12 meters and then down 30. We can find the time it takes. So here we say it has to end up at minus 30, starts at an initial speed of 15.4, and it's subject to gravity. So we can find the time to be just under 4.5 seconds. Now from that time, we can then work out how fast it must be going in the x direction for it to cover 40 meters in the same time. So we know, we apply the Suvat equations, s equals ut plus half at squared, where a is 0, there's no acceleration in the x direction. It covers 40 meters. We know the time is 4.5 seconds, so the speed it must have in the x direction is Vx is equal to 8.91 meters per second. And once you have those two pieces of information, then you can find the magnitude and the direction of the projectile motion. And to answer the question fully, you need to bear in mind that we've just calculated the angle theta with respect to the horizontal. We need to combine that with the second angle theta 2 in order to get the angle relative to the slope. And the final answer is 96.72 degrees.